Okay, so I'm just going to give a whirlwind brief introduction to R, and hopefully for those of you who haven't had much experience with R or kind of rusty, it will sorry, I won't do the admit, but it will give you some knowledge, some new knowledge, or remind you of things that you may have forgotten. I always like to, when I teach, I always like to dig in a little bit into the history. So I just have one slide on that, and then we're going to just jump right into the actual tutorial part. R was built on S, which was a code originally developed by Bell Laboratories, which people have heard of AT&T because it's a popular cell phone provider, but it was prior to AT&T and Lucent Technologies, which you may not have heard of. It was Bell Laboratories. It was created by two statisticians, a New Zealander and a Canadian, Ross and Robert, which is why, so they thought, well, since it's built on S, they gave it an R letter, and it also kind of fortuitously went with their first name. So I thought that was pretty interesting. And they used it initially to teach introductory statistics. And then the core team to work on code was founded in 1997. And then the foundation, our foundation, which still exists, is a nonprofit that was founded in 2003. So it's open source, totally free. It may be a little harder than some of the other softwares to learn initially, but I think it's just so accessible because of it's free. Some of these software licenses for the other popular softwares are really cost prohibitively expensive. So that's my plug for R and the history. So I have a file in our Markdown file that you can follow along in that box folder if you want to download it. The link is in the chat. It is called StatBytes demo. So you can pull that up. For those of you who aren't familiar, I used this file. It's an R Markdown file, which I'm going to talk about, that it can be used to generate slides and other PDFs, presentations. And I used it to generate some slides for the first part of this presentation. And then I'm going to switch back to the code file here. But you'll see that everything in the slides is written here in the file. So there's going to be a talk by Hunter, who is a StatLab tutor, on using R Markdown. So he'll go into that in detail on April 26th, I believe. So now I have to find that file. Here it is. So I generated these set of slides using that R Markdown file, which we'll go back to and which you can have. So today I would like you to learn some common R terminology. And basically, if you get nothing else from this little session, is to be able to import a data, clean it, and manage it from common data file types. Can you see this? Maybe I have to share my screen. I'm not sure. I have to share my screen. Yeah. Okay. So this HTML file is also in that folder. So these are, I'm not going to read this list, but these are the things we're going to go through today in the demo. And if we don't get through all of them, because this is a short session, the R Markdown file that goes through all of these is written in such a way that you should be able to do it by yourself if you want to. Okay, so the basics. For those of you who installed R already in our studio, I would like you to open it, and then we'll just do a really quick tour, and you'll get more of this probably with Hunter's talk in a couple of weeks. But I'm just going to show you here. So can you see me if are you seeing our studio now? Or not?
I still see your slides.
Okay. I'm going to share the desktop so that I can move around. Okay. So now you should be able to see my RStudio, which I opened. Correct?
Yeah.
Okay, so there's several panes in R. The ones that have different things, there's the console pane, which you can ignore, but you can also type things into it. Like if I wanted to add 1 + 1, I could simply tell it 1 + 1, and it will give me the answer. There is the environment, which I look to a lot. This is where I create things or store things, or anything that I create and will be stored in this environment. So I look at that a lot. And then there's the files over here, which you can see all the files that are in that folder that are in box. So that's my it's the same folder that this R Markdown file is in, is what will display there. I don't use plots, but sometimes depending on your plots will render here. I don't think they render here when you're using Markdown, but please correct me if I'm wrong, because they'll render, you'll see, we're not going to do plots, but they'll render right below the code instead of in this plot window. Packages is another important pane. Packages, we'll talk about more what these are, but these are all the things that house the tools or functions that you'll use to do anything that you're going to do in R, plotting, simple statistics, anything like that. And then always I use help a lot. So this help is for the function. So any function that does something, some math or some graphing, you can look it up by typing it in the help, the search part of the help window, and then it will tell you what that function does and how to use it. Okay, so I'm just going to go back to my slides for a bit because they're a bit prettier. So that's the basic tour. So there are 3 general file types you can use when you're coding in R script. A lot of computer scientists I've noticed that I've worked with are people that are more trained like in hardcore statistics, I will call it. When they use R, they'll use R script instead of Markdown. Markdown is kind of a newer thing, so it depends on how long ago they were trained, but that's just code written in a text file that you can run. We'll be using R Markdown, but you can also use R Notebook, which is like R Markdown, but the neat thing about R Notebook is when you generate an HTML file from it, it will also have the code embedded in it that people can access through a tab on that HTML file. So that's kind of cool. And maybe Hunter will talk more about that in a couple of weeks. You can select the file type in R Markdown. So I already have one. If you've opened the StatBytes demo, I've already done this, but you can select the file type by just clicking new file, and you can see there's different options here. I'm not going to talk about any of these others, but there's the R script, the R Notebook, and R Markdown. So you'll get a new document in that file type if you click on those. So let's see. R Markdown and R Markdown Notebook, I'll just mention this, fall under the category of literate programming language files. So you can make really pretty reports, and you can annotate things really well, what your code does. And so it's just really nice and very easy to read these types of files. Okay, so just a little bit more about R Markdown and R Notebook and Notebook files. They end in RMD, and they're highly valuable for making reports. In both file types, code chunks are embedded within plain text that describes what a block of code does or what the code output is. So instead of results showing up in the console or plots window that I mentioned when using an R script file, they show up below the chunk, which you'll see what that is in a minute. And then they can be used to create really beautiful reports using knit. Again, I'm going to refer to Hunter, who's going to give a presentation on this. And these are some of the file types that you can generate with this. So they can really automate things. Like I'll just give a simple example. I'm working with Matt Kruder on a big surveillance project that has several sites, and we want to generate reports each week really quickly for these sites. So we're using our Markdown to automatically generate reports for sites. So we don't have to spend a lot of time customizing the reports every week and plugging in things from different types of files like you would in a Word document. Okay, so one thing I'd like to mention at the top of that R Markdown file is what's called a YAML header. And it stands for, I don't think anybody really knows what it stands for, actually. But I think it was reported on Wikipedia that it stands for YAML Ain't Markup Language. And it's described as a human readable data serialization language. I'm not quite sure what that means, but it actually tells when you knit to a HTML file or Word file, from your R Markdown document, it tells it what kind of file to knit it to. So you can see this is an example of a YAML at the top of the Markdown file, and the output here is HTML format. But if you were going to have Word, it would say Word, and there's some other options you can add in there. Unless you're really experienced with R Markdown and knitting, I would not modify that YAML because you can get lots of frustrating errors until you really know what you're doing. So it won't knit to another file type to create those pretty reports. Okay, I think I'm going to switch back now to the coding file, the R Markdown file, but in the slides, if you're reviewing them, I've labeled all of the headers with the chunk that we're referring to on that slide. So I will show you what that means. So this is a chunk. So this is chunk 1. So on this, it ties to what it says on the slide. So one thing, R is an object-oriented language like Python. So it's not that hard to learn Python if you already know R, because they kind of work a little bit the same in terms of logic. What are objects? These store information in different types. So variables, data frames, functions, lists, or vectors, and they're anything to the left of an assignment operator. For a long time, I didn't have words for what that assignment operator was, so finally spent some time figuring out how to put that into words. So the assignment operator is shown here. It's two keys. So it's it makes an arrow. I don't know what this is called. But it's what?
Less than.
It's it's less than and then a dash. And it's the most common symbol that is used to assign an object on the left to a value on its right. So example, I could type, as I did below in that first chunk, X, I could assign the object X to the value 3. And so that's stored in the, you'll see it in the environment, but it's stored in R. That X means 3. So if we run that chunk, and you can do that just by pressing the green arrow. You can also go up here to press run selected line. But you'll see that you'll have a values pane within the global environment, and it's giving this object X, and the value is 3. Okay, so I can also data frames. This was a little bit weird for me switching from SAS to R, because in SAS we always call them data sets, and maybe the terminology has just changed with time because I learned SAS a long time ago, but data frames are R's version of data sets. So we can create one for X using the below code. So I'm just assigning the object DF And I'm using what's called a function. We're going to go over that called data.frame. And then takes the argument of X. So basically what this tells R to do is take the object X and turn it into a data frame. And so you'll see there'll just be one cell in this data frame with X as a variable and a value 3. Okay, so some other terminology that I think is often not addressed specifically when you learn R, and I had to go back and learn very basic things when I was like, what exactly are these words that are always being talked about? Vectors and lists. So a vector is a list of something. In R, we use vectors and lists a lot. So if we wanted to create a vector of numbers 1 through 5, we could specify it in 2 different ways. And a vector is specified, it has a C and then the parentheses. What does C stand for? Does anybody know?
I think it's combined.
Combined.
I'll look it up while.
Okay, yeah, so still have some more in-depth basic stuff to learn. It's always like that. You're like, you take things for granted and then you go, but what does that really mean? But anyway, that's how you specify a vector. So I can assign X to a vector of numbers 1 through 5. I can also create it a different way. Just shorthand, which is 1:5. So it interprets that as the numbers 1 through 5. And then I can print X and Y by just typing X and Y in R. I'm going to show you this in a second. But there are 2 types of vectors: atomic vectors, which contain a single class of a data type. And you don't really have to know this, it's just kind of background information. It's not, you might, if you get really advanced in R, you might need to know actually what this means, because different functions handle things differently. But for now, it's just background. So atomic vectors contain a single class of a data type, and a class is what kind of object is it? And lists can contain multiple classes of vectors, so of data types. So the C1, 2, 3, 4, 5 is an atomic vector, while this other type of vector here, which contains multiple different classes of data, is a list or a generic vector. So I'm just gonna highlight this so you can see that you get the same thing with X and Y. I'm actually not sure why it does this, but when I type class, which is a function, as I mentioned, we'll get to that in a bit, it gives 2 different classes for these X and Y, even though they look exactly the same when you print them out. One's numeric and one is integer. For some reason, the shorthand C1:5 makes our store that as an integer rather than a numeric. In practical terms, that probably doesn't matter, but just something I noticed. I'm not sure why it does it that way. Go ahead, Janine.
Oh, it's Angela.
Angela.
Can I ask a question?
Yeah.
It might be really obvious, but I'm not sure. So earlier we had X equaled 3, but now we've made the list. So is that replace?
Great question.
Yeah.
I've overwritten.
Okay.
Yeah. So if you assign the same name to something at the right of that assignment operator, you're going to overwrite the previous value. Great question. Sorry, I wasn't very creative when I was like naming things.
Oh, no,
I'm going to later tell you not to name things X and Y and stuff like that. But anyway, so this is I just created my list, which is this. It is a generic vector, and I'll just print that. I'm going to highlight those and print that, and you can see that it prints that list. Actually, one interesting thing is that if you take the class of that, it's a generic vector or a list, but it does store it as a, it doesn't, the type of object my list is, when I create it that way, it's called it's a character object, which we'll talk about in a bit, but what character is. But anyway, there is a list function, and you may need to know this for specific purposes, why you would want to actually make that my list a list object instead of like a character vector. But anyway, you can just use that. I don't actually use lists too much lately. As I've gotten into more advanced things, though, it has come up that I need to actually store something, a vector, as a list. Okay, so now we're going to get into some more terminology. Functions are the workhorse of R. They are made up of behind the scenes codes that perform tasks like getting means, plots, regression results, etc. And they're composed of a function name. So that's the object. My fun is the object I'm assigning this function that I'm creating. Arguments. So in parentheses, you use the word function to create a function. I have an argument. So, and then when I run the function, I can provide the values for that argument. And then the procedure that you want the function to do is in brackets. So this is a very simple function that I've created to create means. You can also use a function called mean that's already built in R, but I just wanted to demonstrate the very simplest thing of how to create a function, which usually if you're a beginner, you don't get to creating functions until you're a little more advanced, but you're going to find a need at some point when you're copying the same code over and over again to do something slightly different. That's when you want to create a function. It will dramatically reduce the length of your code, and your code will be easier to read and that sort of thing. So it created this function called myFun. And then if I run it on X and Y, which remember were vectors of 1 through 5, I'm going to get the mean of those. I can also plug the vector. So I'm giving the value v here, X. So it's gonna say, okay, run the function on X. But I can also just specify the vector directly, and I should get the same answer. You actually don't have to do v equals. It'll just interpret this first value that I put in as what I want v to be. They have to go in order, though. If you have multiple arguments in your function, it has to be in order. You have to specify them in order. Okay, so that works too. And then just to check, you can use the built-in functions in R for calculating means, and I'll get the same number. Okay. So we're going to move on to packages and libraries, which I already mentioned briefly. Packages, they're like this. They are like software. So you install them using the install packages functions, which takes them from something called the CRAN, which is kind of a mystery to me, but it's like they're housed on servers throughout the world that users create them. Janine has one that I use all the time called Odds and Ends. She doesn't pay me to promote it, but it's a really good package for calculating odds ratios and 95% confidence intervals and a bunch of other things. So they contain functions for data management and analysis, and some of them are built in. So like the mean function, I think that's part of the stats package that's built in. So you don't have to download anything from the CRAN to calculate some basic things, basic statistics. But others you have to install. So that's packages, and we're going to show how to install those. And then there's libraries, and this is like, so you can install Word on your machine, but you can't really do anything with Word unless you open it. So libraries open up that package and make all the functions within that package available to you. We're gonna install some packages. If you're running this along with us, you can uncomment this. So commenting means that R will skip over with the hashtag. And then it turns green, it'll skip over that. So it won't recognize that as something you're asking it to do. I don't want to install packages more than once, and these are already installed. So that's why I've commented them out, but you can uncomment them and run them, and then it will install these packages that we're going to use for some things down below. I do have to open the library every time I open R though. So I'm going to open all of these. I'm going to open open the package, I guess, so that I can use the functions. I seldom use this method anymore because my former PhD student introduced me to something called Pacman, which is you have to install it. It's a package called Pacman, but then you can use this function. You can't use pload alone for some reason. I think it must be a term used in other packages. So I specify the package followed by 2 colons so that it knows to take pload from that package. And then I plug in all the libraries in parentheses, and it will, the reason why I love this is because it will check to make sure the packages in the libraries usually have the same name, if not always. It will check to make sure that that package is installed. And then if it's not installed, it will install it. But if it is installed, it will just go ahead and open the library. So it's really short. So compared to having all of this line of code to install and open the packages separately. So I'll just run that. Okay, any questions? Do we need a chance to catch up? Should be, installing packages might take a minute.
I think some people might have gotten that message when they opened the file. Sometimes it says, do you want to install the packages across the top? You get that little yellow pop-up. You won't get it because you already have them installed.
Yeah. If you already have them installed, it might there is a pop-up that'll ask if you want to install them again. Like if I were to do this, let's just do this. I don't know if this is what you're experiencing, but you get that. And for me, I'm just going to say no, because I already have it installed. I don't know why I received this error, but it shouldn't affect anything. I don't know if I just got that. Okay, so any other questions before we move on? Okay, so we're just gonna, this code is gonna be very useful to you if you start using R a lot, because you're gonna be working with a lot of different file types that you might receive from somebody else, or that you download a file from the internet. So I've showed some of the common ones for how to import CSV files, how to import Stata files, tab delimited files, and not PowerPoint, SAS transport files. There's also another, there's a function, I think, specifically for SAS 7BDAT. I don't have that in here. But there's other file types that you can find functions for. So the functions are this read_CSV. These come from Haven, read_CSV, read_DTA, etc. I'm not going to go into this because we don't have the time, but I have housed all of these data sets on my GitHub site. So we're importing them directly from the GitHub site. So this works really well when you're doing a tutorial like this, because nobody has to download the data. They can just import it from this site. But there are some tricky bits to importing data into R from GitHub, depending on the file type. So you can read through that at some point, but this should all work. And what's going to happen when I read all these files is they're going to show up in my environment under data. So you'll see now I have a Starbucks CSV underscore CSV, because that's what I called this object for this data frame from GitHub. And then I've just called them Starbucks data. We're working with Starbucks data. I think I know Janine gave me this data a long time ago, and I still use it because I really like Starbucks, but I don't get paid for promoting them either. So anyway, we just run all those chunks, and then we have all those separate files in our environment. So if we wanted to read a file from our computer instead, there are a few different methods, which I'm going to go over quickly for the sake of time, but you can like read through them when you're faced with, I want to import it from my, not from the web. But I think this file is actually in the folder on Box. And so you should be able to just, if you download that folder from Box onto your desktop and you keep everything in it, you should be able to just run this. You don't need a path name. So you can see now I have this other file that was created in my environment. Same. Another way is to get the path to that file wherever it is. This one is in the Box folder. I've used that path. I'm not going to show you how to get the path, but it's right clicking and I think, well, maybe I will just quickly. For those who don't know, if I can find my Box folder. So here's that file. And if I'm on a Mac, so if I hold down the option, if I kind of right click, it's not actually right clicking, but I press on the mouse on the right and then do copy as path name. That's how I can get that path. It's a little bit different on a PC. So if somebody has good explanation for that, if they could type it in chat, that might be helpful to some working on a PC. Okay, so yeah, as long as it's in the same folder, you don't have to specify the path, but if you want to give it a path, you can also do that. I don't really love the path way of doing it, because if you hand this code off to somebody else, they're going to have to change the path, which, it's just not as reproducible if you can avoid that. And then the other way, which I kind of discourage from using, but sometimes if you have a really tricky file that is difficult to import, is you can use the import data set menu from here, and it will give you code too. But if it'll ask you what kind of file. Sometimes it works and sometimes it doesn't. Usually with really tricky files, it doesn't work. I have to figure out another way, but it's good if you can't remember and you're just trying to get the file in, and then you can paste the code that it gives you into your chunk. Okay. This is what it gave me if I did that. If I would have done that. So one of the first things you want to do after you successfully import your data is characterize it in terms of the number of observations. So you can just look at this data set, the XPT here, and it'll give you information about the data set in the environment, which is 298 observations and 7 variables. You can view it also. I skipped that part, but you can see what it looks like. You can see there's a number of weird problems here. So it's always good to look at your data set. These problems aren't going to affect anything that we'll do, but it's always good to make sure that when you imported it, it looks roughly correct. So you can do that with view, or you can just double click here in the environment too. You can also get the number of columns and rows, or the number of rows and columns by using this dim function. So we can get a basic summary of the variable types in the data set using a supply function. This is nice because it'll give you a summary of all of them at once. So this supply function takes the object, which is the data set in this case, and then if you use the second argument as type of, it will give you the type of variable that is. So we can see we have several different types here, character and double, which is a type of numeric variable, which we'll get to in a minute. To run a function on a particular column, instead of getting them all at once, we can actually use type of too. Use both of those. Class gives us a general class of what type of variable it is. And type of gives us more information. I think this will be character for both, but we'll see a difference between these two functions in a bit. So character variables are text strings, so that when you print them, they'll be in quotes. And just a note, import functions look at several lines of code to detect the type of variables it is, and then it classifies them. So sometimes it can be wrong. But if it sees like dog and boy and a bunch of other character variables followed by the number, or a bunch of other character values followed by the number 10, it's probably going to classify 10 as a character because of the initial data that told it that that column was a character type. Factor variables are categorical variables where observations are assigned to a certain numerical category. And they're dangerous. They can be dangerous, but very useful. So you should use them, but you have to know a little bit about something funny that SAS will, or that R will do with factor variables sometimes. Numerical variables are numbers. Double is a type of numerical. So a class of variable is numerical, and double is a type of numerical variable that is different. It's different from an integer. So because it can include numbers after a decimal point. And integers are just integers, and logical is also known as Boolean variables, which they can take the values of true or false. Okay, so these are, I'm just getting the column names so that we can learn how to rename them. So there's a function called column names. And because our names aren't very nice. So there's a couple of ways of doing this. The first method, I'm going to use the names function. And I don't have to assign any object to this. It will just rename the variables in this data set. And then this is followed by brackets of 1 through 7. So this tells it I want to rename the first 7 columns. So those are indexes of the columns in order that they appear. So you'll see I have the names that correspond to the order in the data set, the new names. Okay, and then suppose I want to rename only one variable, category to cat. I can actually just index the number, the column 2, and assign it to the new a new variable using this format. To give it cat in quotes. So the variable name is specified in quotes. Already run that, but I'll just run it again. I think a lot of people don't use that method. That's using all base functions, but there is a rename function. I think this is in the dplyr package, but I could be wrong. Maybe it isn't. Oh, no, it is. So in this rename function, in the first argument, you tell it that the object that you want to rename something in, and the second argument gives it the specified like this. It gives it the new name followed by the old name. So it's going to rename the column called categories to the new name of calories with all uppercase. I always get that confused, and then you'll get an error, like if you reverse and you do old name equals new name. So if we go to the Starbucks XPT, I already have it up. You'll see that now we have calories renamed. Okay, so converting variables to a different type. These are, I'm showing you in this very brief overview, very commonly used things, like things I practically do daily when I work with R. But these functions will change because you can, if you had, well, you're going to use them all the time. So say your numbers were stored as character variables in a particular column, you're going to want to change them to as dot numeric, or you're going to want to change them to numeric, and you can use as dot numeric. If you want to change a character variable to factor, actually a numerical variable to a factor, you can use as dot factor. I'm going to give some examples of these. Character converts a variable to character, and date converts a character date to a date. And I could probably do 2 hours on dates. So we're not going to get into that, but dates can be very time consuming. I'll just say that when you're working with dates. This is just an important note. Sometimes some of the functions, when they import functions, when they import a data set, will import a column as a factor variable type, and that may not be correct. So you want to avoid actually functions that do that. The read.csv comes to mind. But if you were to not notice that, and then you were to perform like math on that column, your statistics would all be wrong. So so you must first convert a factor variable to a character variable, and then to numeric, again, using as numeric for your statistics to be right. So that's just an important note to keep in your mind, to really check the class of the variable when you import data. And if anything is imported as factor, I'd probably convert it to character so that I don't start doing statistics on that column. All right, so we're going to convert the character variable calories to numeric. And first, I'm just checking what type of variable it is. So it's character, and then I'm using the as numeric function to convert that to a numeric variable. I'm giving it a new name. So I didn't mention to create a new variable, I specify the data set, and there's other ways to do this, but this is just using base. And then the $ followed by the variable name. So that's how you create that new column called calories _n. And you'll see that here. Okay. And then you can see that when I run the class again, it has changed to a numeric variable. We have 4 more minutes. So I think I'm going to skip over this because it's just simple, different statistical functions that you can run on this new variable we created that's now numeric. Standard deviation, mean, median. One thing to notice is if you run a mean on a variable or any of these others where it says na.rm equals true, if you don't have this option, this argument here, na.rm equals true, on some of these functions, you'll get an error if you have any NAs for that variable. So that can be really frustrating. So that's just something to remember, that you need that. For the summary function, you don't have to do anything about NAs. All right. Maybe I think I have like 200 more lines of code, or lines of the the file. Are there any questions right now in our last 3 minutes? I should probably do a part 2. Maybe I will. Yeah, NA removed. Let's see. This just shows about, I'll just go through this last bit, how to delete a column variable. With R, there are many different ways of doing this. I'm showing you a way here called the select function that once I learned how to use these functions from the dplyr package, I use them all the time. It's a really nice package. You might hear it referred to as like tidyverse. There's also a tidyverse package that I think includes all of these functions as well. But anyway, so in this particular function, I'm going to deselect calories and it will remove that column from the data set. So I'm creating this new data set called Starbucks XPT2, and then for dplyr, I specify the original data set, and then it's a piping. So what do I want to do to that? This is a pipe symbol. What do I want to do to that data set? I want to deselect the variable calories, and I do it with the negative sign, so that will remove that column from the data set. So I'll just run this, and you'll see no more calories in there, the all caps. But if I want to do it in reverse, which is longer, I could specify all the variables that I want to keep. Notice there's no negative sign there. And so then that's the other way we could do it. So this is short. It depends on how many variables you're dealing with, which way you want to use. And then I can also just rename the category back to category. Don't have to do that, but and then get the column names again to see that it has been renamed back. All right. So the rest of it just goes through about deleting some rows, creating a new variable, so that some more things that you typically use during data management, and then creating data sets as well, or creating data sets through selecting certain observations. And you can go through all of this. It's pretty self-explanatory, I think, to get through the rest. And I think that should give you a good start to at least data managing and some simple statistics. All right, we're at 101. All right. Does the Stat Lab offer these as well? So Chloe, this is part of the Stat Lab. And all of our videos are from these are, appointments to learn languages. Not really, do we? We don't do that.
No, but if you had something specific you were working on, like if you're working through the rest of this code, you could make an appointment with one of the tutors and I'm sure they could answer your question.
Yeah. I mean, we try to do these to cover that kind of missing piece so people can get brief introductions to various softwares or tools within the softwares. But Stat Labs, just the peer tutor appointments are more to help with just specific projects and things like that. But through that, you will get some additional knowledge in R or data or whatever. Yeah.
I did a tutorial kind of like this in 2021 and I have it on my GitHub with videos. So I put that in the chat if anybody wants it. I should have done that earlier.
Yeah. All right. Well, you were right. It was too long.